I'm Algebra Annie, and I am here to help you be successful in your algebra class. Try to be a rainbow in someone's cloud. Amaya Angelou. Our learning target today is I can evaluate and simplify expressions containing rational exponents. Now we are doing rational exponents.
And before we start our lesson, something that might be very helpful for you, it's been very helpful for my students, is to have an exponents chart. So this is the 1 through 12s all to the second power. 1 through 12 all to the third power. 1 through 12 all to the fourth power. I highly recommend that if you struggle with your multiplication tables, or just if you want something quick to refer to, that you have this kind of a chart readily available right next to you. So the 2s, the 3s, the 4s, you might even want an exponent chart of the 5s. You might even want an exponent chart of the 6s. So just have one kind of close to you. So what I would do is quickly fill it out using a calculator. Now there is a long way and then there's a short way to try and do this on your calculator. You could just do like 2 to the second power, is 2 times 2. Or 6 to the third power is 6 times 6 times 6. So you could type it in the long way. There is a short way to do it, and that's to do what I call the to the button. So if you look on your calculator, a lot of you have a button that looks like this. It's called a little caret when you're in English class. The caret, I call the to the button. So if I wanted to do 5 to the third power, I would have typed in 5 to the, that's why I call it the to the button. 5 to the third power is what 5 to the third power ends up looking like on your calculator. And it will go ahead and tell you what your answer is, which is 125. So go through quickly and fill all of this out using your calculator. So now that you have your chart done, keep it close at hand. We'll always be referring to this for today's lesson. So today we're talking about the definition of b to the 1 over n. So we're still talking about exponents, but our exponents are now going to be fractions. So what is the rule when our exponent itself is a fraction? So a number raised to the power of 1 over n, if it is a fraction with a 1 in the numerator, that is going to be equal to the nth root of that number. So I see that if it's 3 to the 1 over 2, the nth root was, so this is the square root of 3. This is the fourth root of 5. This is the seventh root of 2. So it's a root. So the denominator part of the fraction tells me which root it is when I'm taking the radical of it. Okay, so let's go ahead and try this problem. So the denominator of the exponent tells us what root it is. So since that's a 3, I have the third root of 125. Now if you remember from first semester, if I have a root, if it's a third root, that means I'm looking for one single number that I would have multiplied together 3 times. So one number multiplied together 3 times. This is why we had our chart at the very beginning. So let's go ahead and look at that chart. So here's that chart. Looking for one number 3 times. That means I needed the third roots. So I'm looking for 125. There's 125. So what one number did I multiply together 3 times? 5. So back to my problem. 5 was multiplied together 3 times to give me 125. So my question is, what one number did I put into each of these? 5. So the answer to all of this is 5. You're looking for the one number that you put to each in these spaces. So you're done. Let's go ahead and do the second example. I can see that I'm supposed to take this problem and then add it to whatever the answer to this problem is. So we're actually doing 2 questions side by side. So this question over here, this is a 6th root. So this is the 6th root of 64. We're adding that to, this is the 2nd root. So the 2nd root of 25. So now I got to figure out what is the 6th root of 64. Add that to, what is the 2nd root of 25? So I know I'm going to be adding these together. 6th root. If it is a 6th root, that meant I am multiplying one number together 6 times. 1, 2, 3, 4, 5, 6. One number 6 times. If I'm looking for the square root, I'm looking for one number that would multiply together 2 times. So we're going to take a look at our chart. What one number is to the 6th power? Well, my chart actually doesn't even go to the 6th power. I have 2nd powers, 3rd powers, 4th powers. So either you know your multiplication tables, or you make more lists for yourself, or we do the guess and check method. So let's go ahead and do the guess and check method. Let's see. If these were all 2's, what would I get? So 2 times 2 times 2 times 2 times 2 times 2. If I grab my calculator and I type all that in, that's actually 64. It's exactly what I wanted it to be. So I know that these are, in fact, all 2's. If it wasn't all 2's, you'd have to guess and then try 3's. So these were all 2's. Let's go ahead and do this one. I'm looking for one number that goes 2 times, and equals 25. So my list, I'm looking for one number that does 2 times. Well, here's my 2's lists. I'm looking for 25, 25. There's 25. So that meant 5 was 2 times. So that meant each of these spaces was 5, because 5 times 5 is 25. These have to be the same number. So let's see. What one number was in here 6 times? Well, this was a 2. I'm supposed to be adding. What one number was in here 2 times? Well, that was a 5. So now I have 2 plus 5. What is 2 plus 5? 2 plus 5 is 7. And that's your answer. And you're done. Let's go ahead and practice 2 more problems. So the denominator is a 4, which meant I am looking for the 4th root of 81. If I'm looking for the 4th root of 81, that means I'm looking for one number that would have been multiplied together 4 times. So it means I'm looking for my 4's lists. So let's pull up our list. So here's my list. Looking for the 4's list. I need something to give me 81. There's 81. 3 to the 4th power. That meant I had 3 in there 4 times. That meant I had 3 times 3 times 3 times 3. All of this gave me 81. So the question is, what one number did I multiply every single time? It was 3. So your answer is 3, and you're done. Going over here, I have a question I need to answer, and I'm going to add that to the other question I need to answer. So I know this is going to be an adding problem. The denominator is a 2, so I'm looking for the 2nd root of 121. We are adding that 2. Denominator is a 4, so I'm looking for the 4th root of 256. If it is a 2nd root, that means I am looking for one number that I would multiply together 2 times, and it would give me 121. Let's go ahead and look at our lists. I need a 2nd root, so I'm looking for 121, 121, 121. Found it right down here. So 11 was 2 times. So back over here, I know that if I multiply 11 2 times, I get the 121 like I needed. And I'm supposed to add this to. If it is a 4th root, that means I'm looking for one number that I could multiply together 4 times. So that means I need my 4's lists. I need 256. 256. There's 256. What number did I multiply together 4 times? 4. So back to my problem. 256 was 4 times 4 times 4 times 4. So what number did I multiply together both times? This answer is 11. I'm supposed to add this to. What number did I multiply all those times? It was 4. So now I have 11 plus 4. What is 11 plus 4? That is 15. And you're done. So now the book gives us another rule. The only difference between this rule and the one we did before is that this time the numerator actually has a number. So what do we do if that numerator is no longer 1? It looks like that is what you're going to take the entire parenthesis to the power of. So let's go ahead and try and do these 2 problems. So looking at this question, the denominator is still the root. So I have the 3rd root of 261. But what do I do to this numerator in the exponent now? We're going to take all of this and we're going to take it to the 2nd power. Let's go ahead and write this one and then we'll solve them. So the denominator is still my root. So I'm still the 5th root of 32. But what do we do now that the numerator is not a 1? We put the entire thing in parentheses, and that new numerator is now my exponent. I'm raising all of that to the 4th power. So let's go ahead and actually solve these then. Order of operations tells us that we need to do parentheses first. So my first thing is to come in here and do my parentheses first. So I am looking for the 3rd root, which meant I need something multiplied together 3 times, and it gets 261. Do not forget this entire parenthesis is still to the 2nd power. So I'm looking for my 3rds lists, and I need something to multiply together, and it gives me 216. So looking at my 3rds lists, I need 216. There's 216. 6 to the 3rd power is 216. So going back to my problem, 6 times 6 times 6 multiplied together to give me 216. So what one number did I multiply together 3 times? The inside of this parenthesis, the one number multiplied all 3 times was a 6. Order of operations, so I had to do the inside of the parentheses first. I did the inside of my parentheses first. Now I can go ahead and do my exponents. What is 6 to the second power? 6 to the second power is 36. And I'm done. We already laid this out so that we know how to solve it. Order of operations says we need to do the parentheses first. We're going to come inside and we're going to do our parentheses first. So inside my parentheses, I have the fifth root. If I have the fifth root, I'm looking for one number that I multiplied together 5 times. So there is me multiplying 5 times. And this entire thing is going to be raised to the fourth power. I need one number 5 times. I don't have a fifth lists. I have a second lists, a third powers lists, and a fourth powers lists. I don't have a fifth powers lists. So you either need to make a list of fifth powers, or know your multiplication, or guess and check. So let's go back to our problem. I'm going to try guessing and checking. So what happens if these are all 2's? 2 times 2 times 2 times 2 is 16. 16 times 2 more is a 32. So this is actually 2. So I know that each of these is actually going to be a 32. So I'm supposed to do parentheses first. Inside this parenthesis, I'm looking for the one number that I multiplied 5 times. That one number was a 2. So the inside of the parentheses answer is a 2. But I'm still supposed to raise this whole thing to the fourth power. What is 2 to the fourth power? 2 to the fourth power is 16. And then I'm done. So let's do some more practice problems. This denominator is my root, so I have the fourth root of 16. What do we do with the new numerator since it's no longer 1? You put all of this in parentheses and you raise it to that power. Let's go ahead and do that to both of these so we have them ready to go. The denominator is the root, so this is the third root of 27. What do I do to this new numerator? That is what I put to the power of. My denominator is a 3, so this is the third root of 216. What do I do to this new power? I put all of this in parentheses and I raise it to that second power. So now I have 3 brand new problems that I need to solve. So the fourth root, if I am looking for the fourth root of something, I'm looking for one number that I multiplied together 4 times. And then all of this is still supposed to be raised to the third power. So one number 4 times, and that was 16. So here's my fourths list. 16. There is 16. That 2 to the fourth power was 16. So back on my problem, what number did I multiply 4 times? I multiplied 2. All these 4 times. So order of operations says I have to do parentheses first. So what one number was 4 times? Well, that was a 2. And all of this is still raised to the third power. What is 2 to the third power? 2 to the third power is 8. So my answer is 8. And I'm done. Our next problem. I have the third root. If I have the third root, then I'm looking for one number that I multiply together 3 times. In the end, this whole thing is still raised to the fourth power. I'm looking for the third root. I need 27. So here's my third lists. 27, 27. Here's 27. So 3 to the third power is 27. So going back to my problem, each of these then was a 3. 3 times 3 times 3 is 27. They're all the same number. So order of operations says I have to do the inside of my parentheses first. I'm looking for what one number was all 3 of these times. Well, it was a 3. Again, this is all still raised to the fourth power. So now I'm doing 3 to the fourth power. 3 to the fourth power is 81. So my answer is 81 and I'm done. Our next problem. I have the third root. If I have the third root, then I'm looking for one number multiplied together 3 times to give me 216. And this still all needs to be raised to the second power. So 216. So I'm going to take out my list and I'm looking for my third lists. I need 216. 216. 216. There's 216. So 6 to the third power. So I know that each of these is going to be a 6. 6 times 6 times 6 is 216. So what one number was all 3 of these times? It was a 6. So the inside of my parentheses is 6. And this is all still supposed to be raised to the second power. So what is 6 to the second power? 6 times 6 is 36. And you're done. So now what do we do if we actually have variables here? So there's a couple different ways that we could do it. So looking at this, for the first problem, I have the third root. So here's my third root. X to the 9th meant that I had 9 x's. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 x's. And y to the third meant there were 3 y's. What does this third root mean? This third root means that we have three things being multiplied together. So I need three things being multiplied together. So I'm making these in groups of three. So there's 1, there's 2, and there's 3. So I had groups of 3. Here's a group of 3, there was a group of 3, and there was a group of 3. I'm looking for groups of 3. Here's another group of 3. So looking at just of our x's, how many groups of 3 did we have? We had 1, 2, 3. I had 3 of them. So I had 3 groups of 3 still multiplied together. Looking at my y's, how many groups of 3 did we have? I had 1. So I had 1 of them. So the third root of x to the 9th, y to the 3rd, is x to the 3rd, y to the 1st. That is one way that you could do it. Another way that you could possibly solve it. So solving this problem using another method that we could possibly do. Remember, if I have an entire parenthesis raised to the 4th power, everything in this parenthesis is raised to that 4th power. So looking at this parenthesis part, the x to the 2nd is going to get raised to the 4th, and this y to the 1/2 is going to get raised to the 4th. This 1/2, remember, if your exponent is a fraction, technically we could convert it into a radical symbol, but we're going to use a different method. We know if we have an exponent to an exponent, you can multiply these. So this is x to the 8th. Exponent to the exponent means we're multiplying. So what's 1/2 times 4? 1/2 times 4, we're just going to write it as 1/2 times 4 first so we can make sure we follow along. Now, this whole time, we're supposed to be multiplying by this guy. So we're multiplying by the third root of y to the 3rd. We're multiplying by the third root of y to the 3rd. So looking at this, I have x to the 8th. What is y to the, what's 1/2 times 4? 1/2 times 4 is 2. So it's y to the 2nd. And all of this is still multiplied by the third root of y to the 3rd. So we solved the parenthesis portion. Now we need to solve this guy. Okay, so now how do we finish solving this one? Since this one's already in a radical symbol, let's go ahead and go do it like this guy did. So this is x to the 8th, y to the 2nd. I needed, so this is a third root. If it's y to the 3rd, I have 3 y's being multiplied together. I need to do groups of 3. Well, here is a group of 3. There are no more. So this was x to the 8th times y to the 2nd. We're still multiplying by this one. What one number did I multiply together 3 times? Y. I multiplied y together 3 times. So here's my y. So I only had one group of y's. Well, now it looks like a problem we did a long time ago. I have same basis. If you have same bases of y's, you can add them together. So what is my final answer? This is x to the 8th, y to the 3rd. So we're mixing together our rules. You know what a power to a power does. So we're going to go ahead and do a power to a power. If it's in a radical form, you can solve it like when we did this one. It's a little easier to see. So our next problem, I have the 4th root. So here's my 4th root of, the x is 4 times, 1, 2, 3, 4. This y is 12 times, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Totally ran out of time. We're looking for groups of 4. So here's a group of 4. Here's a 1, 2, 3 group of 4. 1, 2, 3 group of 4. 1, 2, 3, 4 group of 4. So we were looking for what numbers did we multiply together 4 times. Well, right here, this x was multiplied together 4 times. How many groups of x's were there? Only 1. The y's. Y's were grouped into groups of 4. How many of them were there? There's 1, 2, 3. So how many groups were multiplied together? 3 groups were multiplied together. And then you're done. Last set of examples. I've got a fraction, got a numerator divided by a denominator. So we're going to solve the numerator all by itself. So I see an entire parenthesis raised to a power. That meant everybody in this parenthesis is going to be raised to that power. So looking at just the numerator, that x is going to be raised to that power of 2, and that y to the 1/2 is going to be raised to that power of 2. Everybody in that numerator was raised to the power. Well, now we got to look at the denominator. Looking at my denominator, I have the 5th root of x to the 5th. So I have the 5th root of, what is x to the 5th? That meant I had x multiplied together 5 times. So 1, 2, 3, 4, 5. Okay, x to the second is already simplified. He's x to the second. I see two powers close together, so these are going to multiply. So I have y to the whatever 1/2 times 2 is. That's my numerator. Looking at my denominator, I had the 5th root, which means I need to put these into groups of 5. So 1, 2, 3, 4, 5. There's a group of 5. I ran out of stuff. So how many groups of x's did I have? I had just one. So the denominator simplifies x to the first power. So this was x to the second. I need to multiply. 1/2 times 2 is 1. So this is y to the first. All over, the bottom was already simplified as x to the first. I do not have any negative exponents. I do not have any numbers that need to be simplified. However, I do see same bases. If I see same base of x on the top and a same base of x on the bottom, we're going to subtract. So this is x to the top minus the bottom. My y's, the top minus, is there an exponent on the bottom? There isn't. So there was 0 because there's no exponent on the bottom. So what is my final answer? I end up having x to the first power and y to the first power. And I'm done. So looking at our next one, I have the third root of both a number and a variable. So this is a number times a variable. I'm going to separate it. So I have the third root of the number multiplied by the third root of the variable. This way I know a method for dealing with numbers and I know a method for dealing with variables. So I'm going to split them up. So I need the third root. I am looking for 3 numbers that would multiply together to give me 8. And then I'm going to multiply that by, and we're going to deal with this side. So the third root of something that gives me 8. So I need my lists. Third root, I need an 8. Means the answer was going to be 2. So I know 2 times 2 times 2 was simplifying this one. The third root of, looking at my variables, m to the third power meant I had m times m times m. So I needed groups of 3. Well, here's one group of 3. So over here, what one number did I multiply together 3 times? Well, it was a 2. Times by, what one number or what one letter did I multiply together 3 times? He was an m. So what's 2 times m? 2 times m is 2m. And I'm done. Last one we're going to do. The third root of a number times a variable. I'm going to split it. So the third root of my number times the third root of my variable. So the third root of my number, I'm looking for one number that I would multiply together 3 times, and it would give me 27. Here's my lists. Third root, I needed 27. So 3 to the third power. That meant 3 was in each of my spots. So I have 3 times 3 times 3. I need one number 3 times. What number did I multiply together 3 times? This over here is a 3. Now all of this is supposed to be multiplied by, I need to answer this one. The third root, x to the 6th power meant I had 6 of them. So 1, 2, 3, 4, 5, 6. Third root meant I needed groups of 3. So here's one group of 3. Here's 2 groups of 3. So looking at my x's, how many groups of 3 did I have? There were 2 of them. So this is x to the 2nd power. What is 3 times x to the 2nd power? It is 3 times x to the 2nd power, or 3x squared. And you are done.
We learned today, I can evaluate and simplify expressions containing rational exponents, and I look forward to seeing you tomorrow in class.